In this video series, I work through a math problem or problems each video. When we divide two rational expressions, we first change the expression into a multiplication by changing the division sign to the multiplication sign, then replacing the second fraction by its reciprocal. Let's take a look at the example. We need to simplify the following expression. 5x squared plus 40x plus 75 divided by 2x squared minus 2x minus 12 divided by x squared minus 3x minus 10 divided by 6x squared minus 24x plus 18. So we'll go ahead and take the steps we just described, which will be to change this to a multiplication sign and rewrite this as its reciprocal. But let me also factor out anything we can for each of these four polynomials. First, let's take a look at the polynomial for the numerator in the first fraction. We have 5x squared, 40x, and 75. These three terms have a factor of 5 in common, so let me go ahead and factor that out from the polynomial here, and we'll be left with x squared plus 8x plus 1, 5. So x squared plus 8x plus 15. Next, let's take a look at the polynomial in the denominator. 2x squared minus 2x and minus 12. These three terms have a factor of 2 in common, so I'll go ahead and factor that out from this polynomial. And we are left with x squared minus x minus 6. Now we're going to change the division sign to a multiplication sign, and we're going to write this polynomial here in the denominator and bring it up to the numerator. This polynomial has a factor of 6 in common, so I'll go ahead and divide that out. We get 6 multiplied by x squared minus 4x plus 3. And because we can't factor any numbers out from the remaining polynomial, we'll go ahead and already factor this into linear factors. Since the coefficient of the quadratic term is 1, we know we'll get x and x. And 10 can be factored into either 1 times 10, 1 and 10, or 2 and 5. The minus sign here tells me that we'll be subtracting the numbers since they'll end up with opposite signs. 10 minus 1 is 9, 5 minus 2 is 3. Since we want 3, we're going to write 2 and 5. So all these numbers will end up with a plus sign. And since the coefficient of the linear term is minus 3, a negative number, we're going to keep the bigger number negative and change the minus 2 to a plus 2. Now, if we look at the terms already, we should be able to cancel something if they already match. The number 2 here matches the 6 here, so let's go ahead and divide 2 from both of these numbers, and that will give us 3. And we're going to go ahead and write this as a single fraction next, but we're also going to factor each of the remaining polynomials. So I'll copy the 5. When we factor x squared plus 8x plus 15, we get x and x. 15 is equal to either 1 times 15 or 3 times 5. The plus sign here tells me that we're going to be adding the numbers. So 1 plus 15 is 16, which doesn't match, but 3 plus 5 does match 8. And since this number 8 is positive, we're going to make these two numbers positive as well. And let me go ahead and write the rest of the numerator. We keep the 3, and we'll go ahead and factor this polynomial x squared minus 4x plus 3. Once again, we're going to be left with x and x. And then 3 is equal to 1 times 3. And since 3 is a prime number, we can't really factor in any other way. So either 3 factors into plus 1 plus 3 or minus 1 minus 3. But since the number here is negative, the coefficient of the linear term is negative, we know that we need to make these two numbers negative as well. Next, we'll factor the first polynomial in the denominator, x squared minus x minus 6. We get x and x. 6 is equal to 1 times 6 or 2 times 3. The minus sign tells me that we're going to subtract the numbers. 6 minus 1 is 5, which doesn't match, but 3 minus 2 is equal to 1. So let me go ahead and write 3 and 2 here. And since this is a minus sign, we need to make the larger number minus and change the smaller number into a positive number. So we get x minus 3 and x plus 2. And since we already factored the remaining polynomial in the previous step, I'll just copy that here. And now we just go ahead and cancel whatever matches in the numerator and the denominator. X minus 3 matches x minus 3, and nothing else matches. For example, we have a plus 5 and minus 5 here, so we can't cancel them out. So let's go ahead and combine what we can. 5 times 3 is equal to 15. We have x minus 1, x plus 3, and x plus 5. Then, since we have two copies of x plus 2, we can write this as x plus 2 squared, and we have x minus 5. So if we don't have to multiply any of this out, the simplified expression is 15 multiplied by x minus 1 times x plus 3 times x plus 5 in the numerator, and in the denominator we get x plus 2 squared multiplied by x minus 5.